Hello out there. Welcome back today. I hope you're ready. So we'll be looking at some counting principles in mathematics, okay? And remember to do your mathematics, guys. I really encourage you to have a pen and paper, and it's not about observing. You have to try to do some of the problem with us, okay? So let's see what we have for counting principle, okay? Sit there and hope you enjoy. So under counting principle, before we look at that, we have a quick question for you. I'd like you to think about it. What do you think, what is the probability of contracting a COVID-19? Can you really guess that? Surely yes. If you isolate, probably there's a low likelihood of getting that, but also it will depend in which province you are in. We've seen in some province a higher positivity rate, so a higher likelihood of getting the COVID-19. Are we together? So how can we calculate that? We can approximate it based on how many tests were conducted and how many people came positive with the COVID-19. We can really approximate that. But one can say, no, I don't think that's correct because I spend most of my time, I don't social distance. I spend most of my time at home, okay? I avoid large gathering. Surely you will reduce that. That is just an estimation. Fantastic, okay? Try to see that in your own province. Can you really calculate that? Look at that nationally. How does it look like? Okay, fantastic. So what are we going to look at under our counting principle? Also, what I'd like you to look at now is, what is the probability of winning lotto? Sure. It's an interesting question. Can we really calculate? Can we actually win it? Yeah, we do have people that win lotto, but what is the chance of winning it? Okay, I think for lotto we have about 45 numbers. You have to get 6 correct to win the lotto, the jackpot. So we need some counting techniques. How many combinations of 6 are there in 45 numbers? Sure. I think that's a large number. So we have to get 6 correct numbers. That's a jackpot. So I can go with 1, 2, 3, 4, 5, 6. I can select any 6. But how many? We have to think how many combinations of 6 are there. Okay. And how many you're going to bet. So it'll be how many you bet over the possible outcomes, which is a huge number. I'd like you to try that. Actually, if you play once, your number is close to 0. Okay, which is interesting. So when we look at counting, we're going to look at how do we really count that? Okay, fantastic. I hope that makes sense for you. I'd like you to try that, okay? Or if you have something, search engine, just search on that and see what is the chance of actually winning lotto. Okay, great, fantastic. So we're going to look at counting principle as indicated, but under counting principle, we're going to look at choice with repetition. I'll talk about that later. What does it mean to have choice with repetition? Then from there, we'll look at introduction also. We'll start with that. Then fundamental of counting principle, then arrangement without repetition. Okay, repetition with repetition, just clear, okay? So some keywords, what is arrangement and what is counting? What do you think is counting and what is arrangement? How do those two terms differ? Arrangement, I could have chairs and I have 3 people and I have to arrange how they sit. That's kind of an arrangement. But counting is the same kind of counting if I have to count number, 1, 2, 3, 4, 5. How many people in a classroom? How many people in a certain space. But that's not the kind of counting we're going to look at. It's actually more complicated than counting 1, 2, 3, 4, 5, and so on. Okay? Are we all together? Great. So arrangement is when I make arrangement, and counting when I count numbers, okay, or possible outcomes. It's another example of counting. So we will look at that further. So we're going to start now with introduction. So under introduction, let's look at this. Mathematics began with counting. Okay, we spoke about this. Initially, we used our fingers, beans, button were used to help with counting. Are we together? We could count from 1, 2, 3. We can use our fingers. We can use what? Button, and so on. That's the counting we know. Doesn't really differ from that. Okay. But this are only practical for small numbers. It's okay for a small number to use that. But what we have to ask ourselves, what happens when a large number of items must be counted? So this section, okay guys, will focus on how to use mathematical technique to count different assortment of items. Are we all together? Okay, great. So when we started counting, we used our fingers, we used items, all those. But when you have a large number, how do you count? Okay, so we'll look at something of that nature. So let's see. An important aspect of probability, okay? So probability, we know probability, we're talking about chances. Is the ability to determine the total possible outcomes, okay? When multiple events are considered. What does it mean? Okay, so the question we started with about lotto. So we have to ask ourselves, how many combinations of 6 are there? How many are there? It's quite a lot. Let's think about it. I can give you one combination now, which is 45, 45, 46, 47, 48, 49, 50. That's one combination. But how many combinations are there in the lottery? Okay. So that's another way of counting. So for example, what is the total number of possible outcomes? Let's look at something small like this. When a die is rolled and a coin is tossed. Okay, so what do we have to ask ourselves? We have a die and we have a coin. Okay, are we all together? So a die has 6 possible outcomes, which is 1, 2, 3, 4, 5, 6. Are we all together? But a coin has 2 possible outcomes, which is head and tail. Are we all together? So what I have here, I have a coin, and what else? A die. A coin has 2 possible outcomes, which is tail and head, denoted by H and T. What about a die? A die has 6 possible outcomes, 1, 2, 3, 4, 5, 6. If I roll the 2 simultaneously, are we all together? That's what we're going to see what happens. Okay, so if we roll this, how many possible outcomes are there? So let's look at this. What is the total number of possible outcomes when a die is rolled and when a coin is tossed? So to do this, the roll of a die has 6 possible outcomes. We did say it's 1 all the way to 6. And a coin has 2 possible outcomes, which is H and T. Are we all together? So what does this mean? We could have 1 and head when we roll the 2. So if I roll a coin and a die, I could have 1 and head. That's 1 possible outcome. But also I could have 2 and H. A die could give me 2. A coin could give me head. So, and so on. 3 and H, 4, and so on. Therefore, there are 6 times 2 possible outcomes. How do we get that? Because how many outcomes for a die are there? 6. And how many for outcomes for a coin? We have 2. We have 6 possible outcomes for a die. We have 2 possible outcomes for a coin. Then we multiply the 2 and we get 12. Those are 12 possible outcomes if we roll a die and a coin simultaneously. Okay. Fantastic, guys. Okay. I hope this makes sense a little bit. When we come back after the break, we'll look at more fundamentals of counting principle. Stay there and enjoy.